Text analysis allows words to be extracted from strings for the purpose of creating new variables for use in analysis. In this example, we'll extract German word roots from strings with details about online auctions. Here we have the option to perform classification, regression, or clustering that incorporates text analysis, or perform a standalone data transformation to generate variables that can be used later in analysis. For this example, we'll complete a standalone data transformation. First, we'll select the dataset we want to analyze. For this example, we'll use data from the samples folder created when the application was installed. Next, we need descriptions of the data to correctly identify the characteristics of the variables. We can do this by getting the application to analyze the data and then manually validate the results, or by loading an existing description file. For this example, we'll load a description file. The listing title variable contains descriptions of products posted for online auctions. Note that this variable is identified as textual. At least one variable must be identified as textual for text analysis to be possible. Here we can create filters to restrict the data for analysis. For this example, we will not apply any filters. Next, we need to specify the location of the language repository and any language we want to exclude from our analysis. We'll use the default text coding repository and we'll exclude English words from the analysis. Next, we need to choose the language recognition mode. For this example, we'll specify German rather than using automatic language recognition. Here we can specify additional settings for the text analysis. Stop words removing enables words that we don't want to consider in our analysis to be excluded. For example, in English, common words such as and don't add any value to the analysis and can be eliminated. Text analysis works by looking for word roots rather than full words. For example, working and worked are both recognized by the common root, work. Stemming reduction eliminates affixes such as pre or un to limit the number of roots. Concept merging enables the use of a concept list file that specifies alternative words for terms included in the data. For example, the words best and favorite might be merged with the concept positive. Synonym replacement enables the use of a synonym list file that defines synonyms for roots to replace one root with another. When a root is converted into a variable, it can be encoded in different ways. Boolean is the default setting, meaning that the presence of the root is encoded as a 1 and its absence is encoded as a 0. For this example, we'll use the default setting. Here we can see the text fragments highlighted in green, along with the frequency of each root within the dataset. The sample word column displays an example of each identified root in the context of the full string from which it was extracted. We can assess the list of roots to determine which may be useful for future analysis. Now we're ready to generate the model. Here we can see a summary of the modeling results. Note that because we're performing a standalone text encoding, there are no measures of model quality. Now we'll scroll down to see the list of new variables that have been created. A separate variable has been created for each root. We can use our model as a starting point to use other modeling options to find roots that have predictive value. Now we'll save the model. For this example, we'll save the model to the same location as the data source. Next, we'll apply the model against a new dataset to check for the presence of the same root as in our original dataset. First, we need to select the new dataset we want to apply the model against. There are a number of options available for how to apply the model. For this example, we'll use the default method, vectorization. With this method, the output includes all of the columns in the original dataset, along with a separate column for each root identified in the model. When the root is present in a record of the new dataset, the column contains a 1, otherwise it contains a 0. Two other additional columns are included in the output, one to provide the number of elements in the record that are recognized by text coding, and one for the number of distinct roots found in the record. Now we need to enter a name for the model output. Now we'll view the results. Here we can see some of the new columns that have been created to indicate the presence or absence of the German word roots in the new dataset. In this case, we can see that the root Silb was present in several records of the new dataset. You now know how to perform text analysis in SAP Predictive Analytics. For more SAP Business Intelligence tutorials, visit sap.com/learnbi.